solving higher-degree polynomials algebraically can be incredibly difficult. However, by using a graphing calculator, we can visualize these complex functions to find their solutions, also known as roots or zeros, with precision and speed. When degree 3, 4, or higher equations appear, traditional factoring often fails. Graphing allows us to see the behavior of the function and identify exactly where the output value equals 0 along the horizontal axis. Before we dive in, remember the core concept: the solutions to the equation f(x) equals 0 are the x-coordinates where the graph touches or crosses the x-axis. These are the fundamental building blocks of polynomial analysis. The degree of a polynomial, which is its highest exponent, tells us the maximum number of real roots possible. A third-degree polynomial can have up to 3 real roots, while a fourth degree can have up to 4. First, ensure your equation is set to 0. Enter the polynomial into the y equals menu of your calculator. Accuracy is vital here. One wrong sign will shift the entire curve and give incorrect intercepts. If you can't see the intercepts, you must adjust your window settings. Expand the x and y ranges until you can clearly see every point where the graph turns and where it crosses the x-axis. Observe how the graph behaves at the axis. If it crosses through, the root has an odd multiplicity. If it bounces off the axis like a parabola, the root has an even multiplicity, meaning that factor is squared or quadrupled. Most graphing calculators have a Calculate menu. Select the Zeroed tool. This automated feature is much more accurate than simply tracing the cursor along the line, providing decimal precision for irrational roots. Let's look at a cubic example. By graphing y equals x cubed minus for x, we see 3 distinct intersections. The calculator identifies these zeros at -2, 0, and +2. These are our 3 solutions. To use the zeros tool, you must set a left bound and a right bound. This tells the calculator which specific intersection to analyze. Once you provide a guess near the point, the calculator computes the exact value. In this 4th-degree example, the graph bounces at -1 and +1. This indicates that both are double roots. Even though there are only 2 x-intercepts, the total number of solutions still accounts for the degree. Graphs are excellent for finding irrational roots that cannot be written as simple fractions. Here, the calculator gives us a decimal approximation for the square root of 2, which would be difficult to factor manually. If a polynomial of degree 2 or higher does not cross the x-axis in certain sections, those solutions are imaginary. A graphing calculator only shows real roots. If the graph doesn't touch the axis, the solutions are complex. Another strategy is the intersection method. If you have an equation like x cubed equals 5x plus 2, you can graph both sides as separate functions. The x value where the 2 lines intersect is your solution. To summarize, always start by setting your equation to 0. Input the function, adjust your viewing window to see all features, and use the zero to calculation tool to find the precise coordinates of each intercept. Remember, the degree determines the maximum number of solutions, and the shape of the graph at the intercept tells you about the root's multiplicity. These visual cues are powerful tools for checking your algebraic work. Look at this cubic function. Based on the x-intercept shown on the grid, can you identify the 3 solutions? Take a moment to observe where the blue line crosses the horizontal axis. The roots are -1, 0, and 2. By mastering these graphing strategies, you can solve any higher-degree polynomial with confidence. Keep exploring the relationship between equations and their graphs. Generated by Vision Solve AI.